Only the best A-level maths students scored all 8 marks in this question. Most scored less than half the marks. The mean mark was 4.9 out of 10. Let's work through it, so if one like this comes up this summer, you can feel really confident. Figure 2 shows a sketch of part of the curve with this equation. The region R1, as shown shaded in figure 2, is bounded by the curve and the negative x-axis. Show that the exact area of R1 is 20/3 for 4 marks. Let's start with the equation that we've been given and see if we can work out what these values on the x-axis are, what the roots are, the x-intercepts. To find the x-intercepts, to find the roots, we set y equal to 0, because that's the equation of the horizontal x-axis. So replacing y with 0, we get this. And then we can say that either this is 0, so x is 0, or x plus 2 is 0, x is minus 2, or x minus 4 is 0, so x is 4. So to find the area of R1, we can use integration with the limits that we've just found of minus 2 and 0. Obviously 4 would be over here. To prepare this for integration, we first need to expand the brackets. Let's first expand the brackets here to get this, and then expanding again with the x to end up with this. That gives you your first mark. Next, we set up the integral. We're integrating between the limits of minus 2 and 0, and we're integrating what we just expanded there with respect to x. If you write that down, that gets you your next mark. Next, we actually do the integration. How do we do that? Well, we take the old power, add 1 to it, and divide by that new power. So to integrate x cubed, we first add 1 to the power to get a new power of 4, and then we divide by that new power. That's the same as multiplying by a quarter here. We do the same with this term. We add 1 to the power to get x cubed and divide by that new power. And the same here. If we add 1 to the power, we get a new power of 2, and if you divide minus 8 by the new power of 2, you get minus 4. That all needs to go in square brackets with the same limits written on the right-hand side for our next mark. Then we substitute in the limits. Because this is a show that question, it's particularly important that we write down every step of the working here. So when we substitute in 0 as the upper limit, well, all of these will end up being 0, so we can simply write 0. But when we substitute in minus 2, well, we need to write that down as well to show the working. So don't jump straight from this line to the answer of 20/3. Make sure you include this line in full, as I've written here, to score that final accuracy mark. Otherwise, if you skip it and go straight to here, you wouldn't get the mark in this show that question. Next, it says the region R2, that's this region here, also shown shaded on the figure, is bounded by the curve, the positive x-axis, and the line with equation x equals b, where b is a positive constant and b is between 0 and remember this value here that we found earlier, that was 4. So b is somewhere between here and here. It says given that the area of R1 is equal to the area of R2, verify that b satisfies this given equation for 4 marks. So we'll start with the information they've given us, that the area of R1 is equal to the area of R2. Remember in part A we found out that the exact area of R1 was 20/3, so we can substitute that in here. Now that area R1 was an area above the x-axis here, so it would be treated by integration as a positive area, positive 20/3. But this area R2 is beneath the horizontal x-axis, and therefore, when we use integration, integrating between 0 and b, the answer of the integration would come out as negative. So we need to be careful about that. We can say that 20/3, therefore, is the same as the negative version of the integral between 0 and b of the curve that we had here. Remember, we expanded that to get this. Make sure you include that minus sign there, otherwise we wouldn't get this first method mark. We can multiply both sides by -1 to bring that minus sign onto the left-hand side, just to tidy things up. And remember, we've already done this integration in part A, so we can simply copy that down, but now the upper limit is b and the lower limit is 0. Substituting in the upper limit, we'd end up with this, and when we substitute in the lower limit, well, all 3 parts would be 0. Let's try to eliminate these fractions by multiplying every term by 3 and also by 4 at the same time. In other words, we're multiplying every single term, this, and this, by 12. In other words, multiplying each of them by 3 and each of them by 4. That will eliminate all of the fractions to give us this. Next, because we have an equals 0 here in the question, we also need to achieve that by adding 80 to both sides. If you get that far, you get your next accuracy mark. Now, we need to show where this equation comes from. It's not enough simply to say that this equals this. We need to show that in stages to get the mark. But we can use this little hint given here that part of the factorization is b plus 2 all squared. If you expand that square bracket, you end up with b squared plus 4b plus 4. So we know that that must be one of the 2 brackets. What do we know about the other bracket? Well, we know that it has to be a b squared term here, because b squared multiplied by b squared would give us the b to the 4 term. But moreover, we know that it must in fact be 3b squared. Because if this is b squared, we'd need to multiply b squared by 3b squared in order to get the 3b to the power of 4. Similarly, we know that the constant term here must be 20. That's because it must be that 4 multiplies by something to get 80. Well, what's that something? It's plus 20. So you can write in the plus 20 there. But it's a little more complicated to know just by inspection what should go in this position here. So for now, I've just called it alpha, and our job now is to work out what does alpha equal. You could use polynomial long division. You could divide this by this, and that would tell you what would go in here. But that's boring. I want to show you a more exciting and interesting method. That involves comparing coefficients. Let's think about how we could get the minus 8b cubed term. What multiplications here would give us a b cubed term? Well, what could we multiply b squared by here to get b cubed? Well, the only option is this plus alpha b term. So that would give me alpha b cubed. What other way is there of getting a b cubed term? Well, I could multiply this 4b by this 3b squared. That would give me 12b cubed. But there's no other way. This 4 can't multiply anything here to get a b cubed term. So we had this multiplication, b squared multiplied by alpha b, that gave us alpha b cubed. And we also had this multiplication, 4b multiplied by 3b squared, that gave us 12b cubed. You see what I've done there with the factorization? And notice, of course, there are other terms as well, but I just left those blank, putting ... either side. Why have I done that? Well, remember what we're trying to do. We're trying to work out what alpha is. So if this is going to equal this, then it would have to be that this minus 8 would have to be the same as this alpha plus 12. The two coefficients must be equal. So that tells me that alpha plus 12 equals minus 8. Therefore, we can solve for alpha, subtracting 12 from both sides, to get alpha is minus 20. So I can replace the alpha here with minus 20. And then we can simply note that this part can factorize to b plus 2 all squared. And there we have it. We have our final accuracy mark. Next, it says the roots of the equation given here, notice that that's corresponding to this part of part B, are this number and this number, to 3 decimal places. It says the value of b is therefore 1.225 to 3 decimal places. Explain, with aid of a diagram, the significance of the root 5.442. So in solving this equation, which was derived from what we've achieved in part B, we've ended up with two possible answers here. This answer, 1.225, corresponds to the case shown in the diagram in the question, where the area here is the same size as the area here. Remember though that the area R1 is treated by integration as a positive value, and the area R2 is treated by integration as a negative value. But this question's asking us about this other value here, 5.442. Well, that would correspond to a value further than this point here, which remember, we worked out to be x equals 4. So it would be a value to the right of that point. To set up the equation that we achieved in part B, we said that the area R1 would have to equal the area R2. And effectively, we're saying that the area here above the x-axis equaled the area here below the x-axis. Why have we got this second solution? Well, in fact, that means that the area here between B equals 1.225, this area here, is the same size as this area up here. It's just that the green area that I've highlighted is treated by integration as negative, and the orange area is treated by integration as positive. So overall, what I'm saying is that the areas above the x-axis between -2 and 5.442 equal the area below the x-axis. In their report after the exams, the examiners said that the mean mark for this question was only 4.9 out of 10, so less than half marks. They said only the best candidates were able to access the last 4 marks, with many struggling to explain the significance of the root 5.442. They said, as with all proofs, part B proved very discriminating. There was much confusion as to the sign of the 20/3 on the right-hand side. I imagine many students forgot about that negative issue. They said fully correct solutions to part B were rare. And they said in part C that full explanations as to the significance of the 5.442 were also rare and confined to the very best candidates. If a question like that comes up this summer, do you think that you'll score full marks? Let me know in the comments, and let me know if there are any other questions you'd like me to review before those exams.